the note sheet. We got 1, 2, 3, 4. All right, guys. We did one of these yesterday. We're going to do another one of them today. We want to solve this problem here. Now, the reason this is a little different, or similar to the one we did yesterday, but different from the ones we did prior, is that there's no way for us to, as the problem is right now, to get it all in terms of sine or cosine. Because our main way to change from one to the other is our Pythagorean identity. Or cosine squared plus sine squared equals 1, or sine squared plus cosine squared equals 1. Because for us to be able to change from one to the other, we need sine or cosine to be squared. Now to get that, what we're going to do is we're going to take the original problem and square both sides so that we get this sine squared and or cosine squared. Now on the left-hand side, our sine of x plus 1 squared, what we're really saying is that we have sine of x plus 1 times sine of x plus 1. On the right-hand side, cosine squared of x is, well, it's going to be cosine squared of x. Because we're just multiplying it by itself. It is a single term. There's nothing being added or subtracted on that side, so we can just square that single term. We're just multiplying cosine by cosine, which is cosine squared. Now on the left-hand side, we're going to multiply this out. Sine times sine is going to be sine squared of x. Sine of x times 1 is going to be plus sine of x. 1 times sine of x is going to be plus sine of x, and 1 times 1 is going to give us plus 1. We can combine like terms, our sine of x and sine of x. We can add those two together since they are like terms, giving us 2 sine of x. Questions on this here? We're good so far. Yes? Now at this point, the question is, do you want to turn it all into terms of sine or cosine? It's going to be sine, and the biggest indicator is sine of x, the one without a power. Because I can convert or change sine squared into cosine, or I can change cosine squared into sine, but there's nothing I can do for that sine of x. So since I have 2 sine of x as part of our term, it's going to be better to change this all into sine than cosine. So the Pythagorean identity that we're going to use for this here is our cosine squared of x is equal to 1 minus sine squared. Really all we did was subtract sine squared from both sides from our original Pythagorean equation to get here. And we can plug this in. So on the right-hand side, we're going to have 1 minus sine squared of x. On the left-hand side, we still have our sine squared of x plus 2 sine of x plus 1. So now that we do have it all in terms of sine, we only have sine for our trig function, we need to get this equation equal to 0. So one thing we can do is add sine squared of x to both sides, because our negative sine squared of x plus sine squared of x will be 0. We can subtract 1 from both sides, and that will make the right-hand side of the equation be 0. The left-hand side of the equation, we'd have 2 sine squared of x plus 2 sine of x. Questions on how we got to this point here? We feel good about this so far. Now we need to factor. Is there a greatest common factor between 2 sine squared and 2 sine of x? 2 sine of x is in common with both. So we can factor it out of both terms. And when we factor 2 sine of x out of 2 sine squared of x, we're left with sine of x plus 1 is equal to 0. The reason this is nice, or the reason we want to do this, is because now we have 2 or more things multiplied together that equal 0. So according to the zero product property, one of these things must be 0. Either sine of x plus 1 is 0, or we could say 2 sine of x is equal to 0. Well, with our 2 sine of x, we really talked about this yesterday. We could just say it's sine of x, because the 2 is also being multiplied with sine of x. I can't do anything to the 2 to make it be 0, so our main focus is sine of x. Sine of x is already solved for. So we are looking between 0 and 2 pi for our values of x. That will make sine be 0. And there are 2. So I think you're looking at cosine, because sine is going to be the y value. Oh yeah, it is. Thank you. Yeah, I was thinking cosine. You're right. I had it flipped. No, you're right. So 0 is one of them, or pi. Yep. Now,
Or is it 2 pi or is it 0?
so that is, it depends on how they set up the statement. Because if we look back at the top, because we want to solve this on the interval of 0 to 2 pi, since the 0 has the bracket, we're going to pick 0 over 2 pi. Because 0 and 2 pi do have the same value, so it's going to pick one or the other. So if it had parentheses 0, comma 2 pi bracket, then we would use 2 pi.
Oh.
Normally it's going to, 0 is going to be included, 2 pi is not. So it's 0. Sine of x plus 1 equals 0. This one we still have to solve. Minus 1. So we do have sine by itself, and it tells us that sine of x equals negative 1. So we're wanting to know what values of x will make sine be negative 1. This one's our 3 pi over 2, straight down. With sine and cosine, the only time that we'll have one value between 0 and 2 pi is with 1 and negative 1. 1 is only going to have one value. With cosine, it's 0. With sine, it is pi over 2. Sine and cosine, cosine is negative 1 at pi. Sine is negative 1 at 3 pi over 2. Those are the only 2 spots we only have one value. Is with 1 and negative 1. 0 has 2. for both of them. And all of our other values, it has 2. One's and negative 1 is the only time it has 1. So, sine of x plus 1 equals cosine of x. We need to check these values. And the main giveaway, or the main way we know we need to check the values, is since we squared both sides to start with. Now, the first one we can check is when x is 0. So we can say sine of 0 plus 1 is equal to cosine of 0. Well, we know sine of 0 is actually 0, which makes the left-hand side be 1. And we can plug that into the calculator. We just need to make sure it is in radians. Well, actually, sine of 0 in degrees or radians is actually the same amount. Cosine of 0 is also 1. So that works just fine. Next one we can check is sine of pi plus 1 equals cosine of pi. Interestingly enough, sine of pi is 0, so that just leaves us with 1. However, cosine of pi is not 1, it is negative 1. Because cosine is 0, or 1 at 0, and negative 1 at pi, because it has that flip of the sign. Well, 1 is not equal to negative 1, so x equals pi is not one of our solutions. And our last one, sine 3 pi over 2 plus 1 is equal to cosine of 3 pi over 2. With this one here, cosine at 3 pi over 2 is 0. Sine at 3 pi over 2 is negative 1. Plus 1 is 0. So 0 does equal 0. That works. So our two solutions are x is equal to 0 and x is equal to 3 pi over 2. We have two solutions. And since it wanted us on the interval of 0 to 2 pi, we don't have to do the plus 2 pi in to include every possible solution. Questions on this here? Questions on any of this so far? We ready for the next one? Solve 2 cosine of 3t minus 1 equals 0. Now, there are parentheses around the 3t. 3t is inside of our cosine function. The minus 1 is not. I'm not a fan of this kind of notation. They had it written originally 2 cosine of 3t minus 1. And it's the reason that it works that way is it's supposed to be, or we're supposed to understand the fact that there's not a parentheses in front of 3t and one after the negative 1, that they're not both inside cosine. Because if it was all to be contained inside a cosine, it would have been written as this here. Now, since there's not a parenthesis in front of the 3t and after the negative 1, it's supposed to be understood that only 3t is inside of here, like I have it written. It's not that hard to put 2 parentheses. But this is just a kind of heads up reminder. If there's not parentheses and something's added to or subtracted after the sine or cosine, it's not inside. It's going to be outside of it. Now for these here, we're going to treat it the exact same way we've been doing these. It's not any different, except once we get to our answers. So we have cosine here. And the first thing we want to do is get cosine by itself. I really am not going to worry about the 3t at this point. We just want to get cosine by itself. So the first thing I can do is add 1. Telling me cosine of 3t is equal to 1. Then we would divide both sides by 2. Telling me that cosine of 3t is equal to 1/2. Questions on how we got to this here? Okay. Now 1/2 is nice because it's on our unit circle. At what measures does cosine have a value of positive 1/2? Pi over 3. And what's our other one? 5 pi over 3. So we're saying that this angle, which for us is 3t, whatever t is, when we multiply it by 3, we should get pi over 3. And whenever we also multiply it by 3, our other value should be 5 pi over 3. So have we really changed anything? No, it's the same as what we've been doing. We treat it the same. Now again, we're back to these here. It did not tell us the interval for which our angle is. So it's all of it. We have to consider every angle. And for cosine, our period is 2 pi, so we have to add 2 pi in to consider every possible coterminal angle that exists, which is an infinite number of them. So, questions on this here? We feel comfortable with this so far? Because this here, we've done problems like this. Yes? Is t by itself? No, the variable is not by itself. So what do I need to do to get it to be by itself? Yeah, divide by 3, yes? Now, I think you've heard us, both me and Miss Kendall, say we want to wait to the very end to divide. And it's nothing wrong with dividing early. Here, I do have to divide the 3t by 3. I have to divide the pi over 3 by 3. And I have to divide the 2 pi in by 3. I have to divide everything by 3. That's why we wait till the end, especially for solving for variables, because most of the time when we solve, we have one thing on either side. It makes it nicer, it makes it easier. Now with this here, 3t divided by 3 is just t. Pi over 3 divided by 3, we have to reduce it. We can't just leave it. And luckily for us, we can do this here. We can let the calculator do it for us, because really what we're going to end up doing is multiplying it by 1/3. Pi over 3 divided by 3 is pi over 9. Now, I will say the reason we had to reduce that is that we're dividing a fraction. We have a fraction in a fraction. Because the pi over 3 is on top, the 3 is on bottom. We can't have a fraction in a fraction left as part of our answer. Plus, the other we can leave as 2 pi n over 3. We only have one fraction. Top is a whole number. Or the top is an integer. The bottom is an integer. We don't have fractions and fractions. That's fine. Questions on this here? We ready for the next one? Or the other one? Because we also have to divide it by 3. 3t divided by 3 is t. And when we simplify it, we'll get 5 pi over 9 plus 2 pi n over 3. And that's it. So these here, for the most part, aren't too bad. We just have to remember once we get our answer, divide by 3 to get our final answer. That's it. Questions on this here? Did it seem like this one was going to be more challenging than it actually was? Because it did feel like, especially having 3t inside of cosine, we needed to do something extra, something more to get to the answer. But are we ready for the next one? 2 sine of 2t minus the square root of 3 equals 0. First thing we need to do is get this sine by itself. Two sine of 2t equals square root of 3. Then we would divide by 2. Telling us sine of 2t is equal to the square root of 3 over 2. Unit circle. We're trying to find where sine is square root 3 over 2. And that's going to be in the first pi over 3 and I don't think it's going to be pi over.
We're looking at X or Y?
We're looking at y. X, and it'd be 2 pi over 3?
Yeah.
Now, the reason I was hesitant on accepting pi over 6 is because for most of these, if you look at, say, the y value for square root 3 over 2, positive, negative, at this point doesn't matter. At pi over 3, sine does have the square root 3 over 2. At 2 pi over 3, it has the square root 3 over 2 for y, yes? At 5 pi over 3 down below, the denominator is still 3. Sine has that square root 3 over 2, it's just negative. And our other one, which is going to be it's 4 pi over 3, 5 pi over 3. Down at the bottom two quadrants, still has that square root 3 over 2 for sine. You all notice that? And that's kind of the reason, because if one of them has that division of 3, the rest of them are probably going to have that division of 3. Does that make sense? That's the only reason. And doing this long enough and recognizing that, that's the only reason I picked it up. Okay?
Yeah.
Yeah, and that there means nothing on a whole, because that's more me just verifying and checking in my own head. For y'all, all you're going to need to do is look at the unit circle and see where is the y value, square root 3 over 2 positive. 5, or pi over 3, 2 pi over 3. Questions on how we got to this here? Now, because it's not restricted, we have to add sines period to it. And the period for sine is 2 pi n, or 2 pi. And the last thing we need to do is to what? Divide by 2. We're going to have to divide everything by 2. 2t divided by 2 is t. Pi over 3 divided by 2. The 30xs, I would use it, not the graphing calculator. Mainly because it will leave it as your answer in terms of pi. Pi over 6. Now, unlike the last one, 2 pi n, can I divide it by 2? It should just be pi n. And if we do our 2 pi over 3 divided by 2, we actually get pi over 3. And funny enough, we did get pi over 6. Questions on this here? Are you ready for the next one? All right, let's look at this one here. 3 tangent of x over 2 plus 3. We need to get tangent by itself. So the first thing we're going to do is subtract 3 from both sides. Telling us 3 tangent of x over 2 is equal to negative 3. Then we're going to divide both sides by 3. Telling us tangent of x over 2 is equal to negative 1. So I'm going to get you a unit circle. I keep saying that. Let you use that for now. So, questions on how we got tangent by itself. Now, unfortunately, tangent is not on the unit circle. Well, it is and it is not. It's not directly listed like sine or cosine. But it is sine over cosine. We can also look at the back. Because Cooper, yours is on the front side, right there at the bottom. That little grid. So, tangent, we're looking for, well, here, negative 1. But where is tangent 1? At 45 degrees or pi over 4. Kind of is what I was saying earlier with the fact that our sine being square root 3 over 2, it's all the ones with that division of 4. So really, we're looking at the front side and seeing where's tangent negative with our pi's over 4. So if we flip it back over, yep. And we look here, so at pi over 4, tangent's positive. Tangent's positive 1. At the next pi over 4, 3 pi over 4, tangent is negative. So 3 pi over 4 would give us a negative value for tangent, which means it would have to be negative 1. Because at all of our pi's over 4, so pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, it's either going to be positive 1 or negative 1, depending on tangent's value. If we look at the third quadrant, tangent is positive. Fourth quadrant, tangent is negative. So that means the pi over 4 for this here, which is 7 pi over 4, would be our other value. Questions on this here is how we got tangent's values. Because if tangent is nice on one of the 3, we can use the backside to figure out which reference angle, the bottom of it in radians, to get the rest. Now, unfortunately, it did not give us a restriction between 0 and 2 pi, so we have to add tangents period to it. For tangent, its period is pi, so we're going to add pi in to both sides. Questions on this here? Now we need to get x by itself, and we can do that by multiplying everything by 2. Because our x over 2 times 2 will give us x. 3 pi over 4 times 2 would give us 6 pi over 4, which is the same as 3 pi over 2. Plus 2 times pi n is 2 pi n. And we do the same thing to the other side. The 2 and 2 would cancel. 7 pi over 4 times 2 is the same as 14 pi over 4, or 7 pi over 2 plus 2 pi n. Questions on this here? Now, one thing I will say with this here, if it didn't give us, if it told us that we were restricted on 0 to 2 pi, to find all of them, we would just start plugging in values for n, starting with 0. So how that would look is I would start off with n is equal to 0. Well, that would just tell me that x is just 3 pi over 2. And when we say n is equal to 1, so we'd have x is equal to 3 pi over 2 plus 2 pi. And if this goes outside of 3 pi over 2, or outside of 2 pi, 3 pi over 2 plus 2 pi, which this first one will. Seven pi over 2, that's way too big, so it's not included. Really, for this here, most likely it's just going to end up being just the 1. And 7 pi over 2 is actually way too big, so that ends up being the same. So, because we just have to keep plugging in the values of n until we have all the values between 0 and 2 pi. But here, it just works out to be the 1. Nope, too far. Questions on this here so far? All right, let's do this one here. Again, just like the last one, we need to get tangent by itself. So the first thing we can do is add 2 to both sides, telling us 2 tangent of x over 2 is equal to 2. Then we would divide both sides by 2, telling us that tangent of x over 2 is equal to 1. Pi over 4 is one of them, yes. And incidentally, these are both going to end up giving us the same angle, but.
Did you get
So I went, at the other spot where tangent is positive is in the third quadrant. And it's pi over 4. It's 5 pi over 4. Because all of the 45s, so the other 45 or pi over 4 would be our 5 pi over 4 because tangent's positive in the first and third. But interestingly enough, for tangent, these are actually the same measure. Now, since we're not restricted on the interval from 0 to 2 pi, we have to add pi in to both sides. And lastly, we're going to multiply everything by 2, because here our 2 and 2 will cancel, giving us x by itself. Pi over 4 times 2 is going to be pi over 2 plus 2 pi n. And we can do the same thing over here. Multiply both sides by 2, so the 2 and 2 will cancel, giving us x by itself. 2 times 5 pi over 4 is going to be 5 pi over 2. And then our 2 times pi n is going to be 2 pi n. And that there would be our answer. Questions on this here? Secant squared of x minus 2 tangent of x equals 4. Now look at this one here again. We're going back to our Pythagorean identities. Tangent squared of x plus 1 is equal to secant squared of x. Now this is kind of nice because we are able to replace secant in this here with tangent, which would give us an equation where our only trig function is tangent, which will make this a lot nicer, a lot easier to work with. Once we get it all in terms of tangent, we do need to get this equal to 0. So we can subtract 4 from both sides. Telling us that tangent squared of x minus 2 tangent of x minus 3 is equal to 0. Now the nicest way for us to be able to solve this here is to be able to factor it, 2 sets of parentheses being multiplied together. Since the third term is negative, our signs are opposite. Factors of tangent squared, our first term is just going to be tangent of x in tangent of x. Factors of 3 are 1 and 3. 1's going to be positive, 3 is going to be negative. And if I were to check this here, tangent of x times negative 3 would be negative 3 tangent of x. 1 times tangent of x would be plus tangent of x, giving us our negative 2 tangent of x. Questions on how we factored this? I know I'm moving at a little bit brisker pace than we did the last few. But we feel good about getting to this point. Yes? All right, since we do have two things multiplied together to equal 0, one of these has to equal 0. Tangent of x plus 1 equals 0. Solve this here, we would subtract 1 from both sides, telling us tangent of x is equal to negative 1. Now really we didn't need to do, I was realizing this here. Well, tangent of x equals negative 1. Our x value for this here is, see here, because that'd be pi over 4, so 3 pi over 4.
Would it also be satisfied?
It would be, yes. And since it's not restricted on the interval of 0 to 2 pi, we have to add its period of pi in. Now what's interesting with this here is actually if you add pi to 2 pi or 3 pi over 4, you actually get 7 pi over 4. So it's going to alternate between these two. So we could make it one statement. I would take both because they are essentially the same statement. Questions on this first part here? Now we need to do the other part. Now tangent of x can equal 3. Because tangent, the value for tangent can be very big and very small numbers. Sine and cosine are the only ones that are restricted, or for our main base 3, between -1 and 1. Now for us here, to find x, we're going to have to take arctangent, our inverse tangent of both sides, or our inverse tangent of 3, because 3 is not on the unit circle. Because if we were to take tangent inverse arctangent of 3, we would get this here, which is not a nice number. But for us here, we're going to leave it as arctangent of 3. That's it. As the other one we would get from the fact that arctan period is pi, so it would flip over to the other side. And that's it for that there. Questions on these here? We will finish this tomorrow. Yep. G squared. Okay.